In this video, we are going to talk about section 2.2 from the book, okay, which is the differentiation rules. So last time what we did is we defined the derivative of y equals to f of x. The notation for the derivative is you can denote by y prime. You just do the prime on y, or f prime of x, or sometimes we write dy over dx, okay, dy over dx or dfx over dx. These are the notations we use for the derivative, right? But what is the meaning of the derivative? What is the definition of the derivative? What is the formula of the derivative for any function? We gave the definition of the derivative by the limit process, okay? So the limit definition of the derivative is dy over dx, or you can write y prime or f prime of x is limit h tends to 0 f of x plus h minus f of x divided by h. So you can write delta x instead of h there. You can write limit delta x tends to 0 f of x plus delta x minus fx divided by h. You can do that too, but this definition is called limit definition, or defining the derivative using the limit, okay, or limit process. All right. Also last time, another thing that we did is dy, if y equals to x to the n, if there is just x and then some exponent of x, if there is no any number before x, right, there is no any number below x in the denominator of x, we have just x to the n, then the derivative is y prime equals to that exponent goes to the front, n, and then x, and then 1 less than that exponent, that is nx n minus 1, okay? Or you can write dx to the n over dx, exactly the same thing but different notation, okay? This is one notation, this is another notation, is equals to nx n minus 1. And another thing is, if y equals to a constant c, there is no x, there is just a number like 5 or 4 or just a constant c, then the derivative is 0. Do you remember how did we find the derivative of this? What we did is you can write c equals to c times 1, right, and then c times x to the 0, right, and just pull that c out, and then the derivative of x to the 0 is 0x to the n minus 1, that is 0 times something, 0 minus 1, right? 0 times something will be 0. That's how we did that. But why can you pull that c out and find the derivative of x to the 0 only? We will discuss that later, okay? But yes, that is the derivative of a constant, that is always 0. And the final thing that we discussed last time is what do you get with f prime of x is basically slope of fx at x, right? Basically the derivative of a function gives you the slope of the function basically at a point x, okay, at a point x. So but this is called the limit definition, okay, but we don't use the limit definition when we find out the derivative because it is too long, okay? Limit definition is usually used to find out the formula of the derivative of different types of function, okay? So when we do the problem finding the derivative, actually we don't use this limit definition later. There are shortcut way to do that, like we use that formula directly, okay, that formula directly. But to find out the formula, to derive the formula of derivative of function, usually at the first time we use the limit definition, or we use the limit process, okay? So before I go to the shortcut formula, what I'm going to do is I'm going to find out the formula for derivative of y equals to sine x, or fx equals sine x and y equals to cosine of x. Let's do this. Solution is we have fx equals to sine x, right? So what you want to do is you want to find out f prime of x, right? What is the formula? Limit h tends to 0 f of x plus h minus fx, right? And then divide by h, okay? Now what is the value of f of x plus h? Limit h tends to 0 f of x plus h will be x replaced by x plus h. You will have sine x plus h minus sine x, right? Because fx plus h minus f of x is sine x divided by h. You see that? That is divided by h. Then what? So then what you do is you use the formula of sine x plus h. Do you remember the formula of the sum of the sine? The sine a plus b is equals to sine a cosine b times cosine b, right? And then plus cosine a times sine b. This is the sum of the sine formula. You cannot distribute sine a plus sine b that way. Sine is a trig ratio, works differently for the sum, okay? It does not distribute straight. So this is the formula to find out the sum of the sine, okay? So what you do here then what you do there is basically, so equals to limit h tends to 0. What I'm going to do here is I'm going to use that formula. It will be sine x times cosine h plus cosine of x times sine of h, and then minus sine x is still there, right? Sine x divided by what? h. You see that? This is what you will get. Now, if you look at this, what do you get there? Then you see that there is basically, let me denote that this has sine there, this has sine, okay? So I want to factor that sine out from those two terms, and then I will keep that same, the middle term same, okay? So how do I do that? Is basically this is equals to, let me do that, sine x take out, you write cosine of h minus 1, and then plus cosine x sine h, right? There is a times in the middle and there is a h in the denominator. So what I want to do next is I want to write the I want to split the denominator. So you can write this as limit h tends to 0, right? You can write sine x times cosine of h minus 1 divided by h, and then I can distribute the limit as well. Limit h tends to 0 cosine of x times sine of h divided by h. You can write that way, right? So if you want to, you can write 1 minus cosine h here and then write a negative sign there, okay? So what I want to do here is, let me do that one more time. So basically you can write limit h tends to 0. I can write minus sine x 1 minus cosine h divided by h. Why do I do that? Because I know that the limit formula, limit h tends to 0, 1 minus cosine h over h is 0, right? I want to use that formula. That's why I'm trying to write this in that form. And then plus limit h tends to 0, you can write cosine of x times sine h over h, right? So look at this. What do you get there? You see that limit h tends to 0, that is 1, right? And limit h tends to 0, that thing is basically 0, right? So sine x times 0 will be, this thing will be 0. The first term will be 0. The second term will be cosine of x. 0 plus cosine of x will be just cosine of x, right? Which is the formula. So you get that this is equals to cosine of x. So you see that the derivative of sine x is cosine x, right? So if you want to, you can write this way too, if you want to. So you can write d over dx sine x equals to cosine of x. See, because we were taking fx equals to sine x, right? We were taking fx equals sine x, and we got f prime of x equals to cosine x. The another way of writing exactly the same thing is d over dx sine x is equals to cosine of x. Okay, so I want to do for the formula for the cosine x. So in other words, the derivative of sine x is cosine x. That's what it says, right? The derivative, that d over dx is the derivative, or the prime is the derivative. So the derivative of sine x is cosine x. That is the formula. In the future, we will not do this way to find out this derivative of sine x. We just use cosine x. We just write cosine x, okay? Similar thing I want to do for cosine x. So what is y prime then? Solution. So here y prime is equals to limit h tends to 0, right? And then you do f of x plus h minus f of x divided by h. So what do you get? Limit h tends to 0, cosine of x plus h minus cosine of x divided by h. Similar to the sine, what is the formula for cosine a plus b? So the formula for cosine a plus b, sum of the cosine, right? Sum of the cosines. So cosine a plus b, cosine of the sum. Here it is sine of the sum, here it is cosine of the sum. You cannot distribute cosine a plus cosine b, okay? What is the formula is cosine a times cosine of b minus sine a times sine of b. This is the formula for cosine a plus b. So now what I want to do here is I want to basically use that formula for the first term, okay? So that will be limit h tends to 0, and then cosine x plus h is cosine x times cosine h, right? And then minus sine x times sine h, and then minus cosine x is as it is, cosine x divided by h, right? As in the sine, I will try to factor out, okay? I will try to factor out. So how do I factor out that? So there is cosine of x, there is also cosine of x. If I do that, then I will get, so let me do that, then I will get cosine of x out. It will be cosine of h minus 1, because if you take cosine of x out from these two terms, and then minus the middle term is as it is, sine x times sine of h divided by h, right? As we did here, what we do next is I want to split the denominator, meaning what I want to do is limit h tends to 0, okay? It is cosine of x times cosine of h minus 1 divided by h, and then minus limit h tends to 0. I'm distributing limit as well, I can do that, okay? Sine x times sine of h over h. You see that this term will be how much? So this term will be basically 1 with the limit h tends to 0, right? How about this one? As before, you can write negative cosine x and then write 1 minus cosine of h, right? So you can write negative cosine x and then times 1 minus cosine h, meaning I'm taking the negative 1 outside. If you do that, then 1 minus cosine h over h, limit h tends to 0. So this quantity will be basically 0 and that quantity is 1. So what is left is basically you get limit h tends to 0 sine x. It just negative sine x there, right? There is negative sine, so negative sine x. You see that? So what we learned from here then? So what we learned here is we got that d over dx sine x is cosine of x. This is one formula. And another formula is d over dx, the derivative of cosine of x, is negative sine x. This is another formula, okay? These are the two formula we just learned by the limit process. We find out this by the limit process, okay? We use the limit process to find out these two formula. So the similar method can be used to find out the derivative of secant x, tangent x, cosecant x, and cotangent x, okay? So next I want to list all the formula that we will need to use to do the problems, okay? That is the direct method or the direct formula. Okay guys, let us see the list of the formula there. Let us first list all the formula that we have so far. The first formula is, we call this is power rule, okay? Power rule, okay? So the power rule says that the derivative of x to the n is n, that goes to the front, and then x n minus 1. So once you use that formula, you don't have to write d over dx, right? D over dx is gone. So this is basically the derivative. That d over dx is same as the derivative. You can write this as like this, x to the n, and then prime is nx n minus 1. This is the same thing, okay? Nx n minus, let me write n minus 1 in the exponent. So you can write that way too. So that's what they say. They have the same meaning, okay? So also the derivative of a constant, if there is a number without any x, then the derivative is 0. So the next thing we learned is derivative of sine x is cosine x. In other way, you can do sine x prime is cosine of x. This is another way of writing that. You can do that for all those formula, but this is another way, okay? The derivative of cosine x is negative sine x. The derivative of tangent x is secant square x. You can derive this formula too. Just do the method that we did for sine and sine x and cosine x, okay? So the derivative of tangent x is secant square x. Similarly, the derivative of secant x is secant x times tangent x. The derivative of cosecant x is negative cosecant x times cotangent x. The derivative of cotangent x is negative cosecant square x. Okay, so you see that. So how many of them have the negative sign? This one has negative sign, this one has negative derivative, and this one has negative derivative. If you want to memorize this, I mean, you need to memorize the derivative formula. This formula 1, 3, 4, 5, 6, 7, 8, 9. You need to memorize this so that life will be easy. Okay. So you see that if the trig ratio start with C, like this one start with C, this one start with C, this one start with C, then they have a negative sign and for the derivative, right? But if it is not started with C, then the derivative is not negative. Okay. So some properties of derivative is, if there is a number k multiplied to a function fx, you can pull that k outside. You can pull that k outside, okay, outside of the derivative here, and then find the derivative of fx only. You can do that. Again, if a number is multiplied to a function fx, and if you are finding the derivative of the product of a number and a function, then you can pull that outside the derivative and find the derivative of function only. Similarly, if there is a sum of two functions or the difference of two functions, this is difference, right? Then it is same as finding the derivative separately and then adding them. So what we say is the sum of the derivative, the derivative of the sum, right? The derivative of the sum or difference is equals to sum or difference of the derivative. So you can find the derivative of fx separately and derivative of gx separately and then add them or subtract them depending on what sign do they have in the middle. Okay, let us do some examples. Okay, so fx equals to negative 5. So what will be f prime of x? Look at this. The formula number 2, right? There is no x on the right side. So it is just a constant. The derivative of constant is 0. That's the answer. Now number 2, y equals to x to the 1/3. The formula number 1, right? You have x to the n. So you can write 1/3 times x to the 1/3 minus 1. You see the formula nx n minus 1. So now you need to simplify this, okay? So 1/3 is there. What is x to the 1/3 minus 1? So you can write 1/3 minus 1 is basically, you can write 1/3 minus 3/3, right? So how much is that? 3. 1 minus 3. 1 minus 3 is negative 2, right? You can write negative 2/3. You see that? But if you want to write in the better form, since this has a negative exponent, you move that to the denominator, right? You can write 1 over 3x to the 2/3. If you want to be even more nicer, you can do 1 over 3, and then these 3 in the denominator of the exponent goes to the cube root, and then that x to the 2 will stay there, x square. You can write that way. Okay, so that is the very final form. You cannot further simplify from here. All right, so you can do that way. Now in example 3, you have 3 different terms. So what you can do, you can find out the derivative of the first term, derivative of the second term, derivative of the third term separately. Okay, so what we do there is, so you find out the so let me write down y prime there. So if you do that, then y prime is the derivative of 5 times x cubed. It is same as 5 times, what is the derivative of x cubed? Because see, the property number 1 here, it says that if there is a number multiplied to something, then you can pull that number outside and find out the derivative of that function only. So I'm pulling 5 out, and I want to find out the derivative of x cubed only. What is the derivative of x cubed? It is 3x to the 3 minus 1. I'm using the formula number 1, right? Similarly for the second term, 3 times, it is like 2x to the 2 minus 1. 2 times x to the 2 minus 1. And then minus the derivative of 8 is 0, right? So if you simplify, what you get? It is like 15x to the square, right? And then plus 6, 3 times 2 is 6, times x to the 1 is just x. That's it. That is the final answer. Okay. How about this one? Number 4. So here f prime will be, by the way, before I find out the f prime, what I want to do is I want to simplify this, okay? I have to simplify and write in the formula ready form, meaning that so that I can use the formula directly. How much is this? You can write 7 over x to the positive 1/2, right? But this formula says that you need to have everything in the numerator to use the formula, right? So I want to move this. So if I move this, what happens? It will be 7x to the negative 1/2, right? That move to the top, and if you move the bottom term on the top, the exponent will be changed by its sign, and this will stay the same. And how about that one? Plus the 5 times x to the negative 1. That's what happens, right? You see that? So this will stay the same. That 7 over root x becomes 7 times x to the negative 1/2. Now I want to find out f prime after that. So what is f prime? It will be 7 times, it is like x to the n, right? So negative 1/2 to the x times x to the negative 1/2 minus 1. Nx n minus 1, right? And then minus 3. What is the derivative of sine x? Is cosine x. Cosine x. And then plus, there is 5, right? 5, and then the derivative of x to the negative 1 will be negative 1 times x to the negative 1 minus 1. You see that? Now if you simplify, you will get negative 7 over 2 x to the negative 3/2. You see that? Minus 3 cosine x. And then minus 5. Why? Because there is 5 times negative 1 is minus 5, and x to the negative 2. Now if you want to write the nicer form, that will become, because this negative exponent, we don't want to keep the negative exponent, so you need to move this to the bottom, right? And move this to the bottom. That will look like negative 7 over 2 x to the 3/2, right? And then minus 3 cosine x, and then minus 5 over x squared. So you can write that way, okay? But if you want to be even nicer, this term, that x to the 3/2, can be written as 2 and then square root of x cubed. You can write that form. Negative 7 over 2 and then x square root of x cubed. Why? Because that 2 in the denominator of the exponent goes inside that angle, that 2 there. But if there is 2, you don't have to write 2. It is called square root, okay? All right. So let us do another example that has y equals to 4 over 3x to the negative 2. So how do I write that? Let us rewrite this. You can write 4. Since everything has the negative exponent, I want to move this to the top. That will be 3x to the positive 2, right? So you can write this as 4 times 3x squared is 3x times 3x. That is 9x squared. That is basically 36x squared. That is the rewrite form, right? 36x squared, because 9 times 4 is 36, and then times x squared. Now if you want to differentiate this, 36 times, what is the derivative of x squared? Let me write y prime, okay? So that is y prime equals to 36 times the derivative of x squared is 2x to the 2 minus 1. So this is basically, if you write the simplified form, that will be basically 72 x, because x to the 2 minus 1 is just x to the 1, right? That's what you get. Okay, next example is, if fx is 8x plus 1 square, then find f prime of x at 0, 1. You will find out f prime of x first, and then you plug in x equals to 0 and y equals to 1 if there is any y. So what you get here is f of x equals to, let me write this in the simplified form, that is like 8x plus 1 times 8x plus 1. Why do I need to simplify? Because there is no formula that has like some number times x plus 1 and then square. We have just x to the n, but there is not just x to the n. There is ax plus b type of form, right? There is 8 and then 1 also. So you cannot use that formula directly. So you need to simplify. So that will become 8x times 8x is 64x squared plus 8x times 1 is 8x plus 1 times 8x is 8x also. So 8x plus 8x will be 16x plus 1 times 1 is 1. This is fx. Now I want to find out f prime of x. So let me write down that f prime of x will become 64, that is constant. Now find out the derivative of x squared is 2x, right? it is 2x 2 minus 1, that will give you 2x, plus 16 times the derivative of x is 1, right? Plus 1 times 0, so the derivative of 1 is 0. So you can write that is 128x plus 16. But you want to find out f prime of x at x equals to 0, right? So what you do, f prime at 0, x equals to 0 is, just replace that by 0. So 128 times 0 is 0 plus 16. So the final answer is 16. That's what you get. Also, example number 7. So how do I find out the derivative? There is a numerator and denominator, right? We don't have the quotient rule. We don't have formula if there is x in the denominator and x in the numerator. Only the formula we have is x to the n only. So how do I do? You split the denominator. So you can write f of x. Okay, by the way, see on this example and this example, also these examples, we find out that the derivative after you simplify only. After you write in the form that you can use the formula directly. You first write down in that form and then use the derivative formula, okay? So what I want to do is I want to write x cubed over x squared, right? Minus 4x squared over x squared, and then plus 5 over x squared. So what is left? So x cubed over x squared, you cancel with that, so x, and then x squared and x squared will cancel out, minus 4 plus 5 times x to the negative 2. I move that to the top so that I can use the formula directly. Now what will be f prime of x then? Here I didn't find the derivative. I rewrite the function fx. Okay. Now I found out the derivative. What is the derivative of x? Is 1 minus derivative of 4 is 0, and then plus 5 times derivative of x to the negative 2 is, it is like x to the n, right? So it is like n negative 2 and then x negative 2 minus 1. That will become 1 minus 10 because this is gone, right? So 5 times negative 2 is minus 10, x to the negative 3. So that can be written as 1 minus 10 over x cubed. So this is the final form of the answer. You see that? So when you write down the answer in your online homework may be picky about which answer do you plug in, okay? So you can try plugging in this first, and then if it says wrong, and then you can try plugging in the simplified form, okay? So I think you can try 3 times or 5 times, I don't remember. So you can plug in answer 3 times or 5 times until you get right answer. So you will not be penalized, okay? But after, if you try more than 5 times, then that answer will that question will disappear, and you will have to practice a problem, similar problem, and then a different problem will show up instead of that problem, okay? So you can try 4 or 5 times. I think 3 times, if not 5 times, you can try that for without penalty. Now I want to find out the y prime of this function, okay? Let me write down in the simplified form, t to the 1/2, right? And then plus 7t to the 1/3, right? Because how do I write? There is 1 in the exponent of t, that goes in the denominator of that exponent, and then minus t to the 3/2. Now if you find out the derivative, then that will be 1/2 t to the 1/2 minus 1, okay? This is function of t. This y is basically ft, function of t. That's why when you find the derivative, we find out with respect to t, okay? So this is like t to the n, so use that formula, n t n minus 1. If there is x, you do n x n minus 1. If there is t, you do n t n minus 1, and then plus 7 times 1/3, and then t to the 1/3 minus 1, minus, and then 3/2 t to the 3/2 minus 1. What do you get? This is like 1/2 t to the negative 1/2 plus 7 over 3 t to the negative 2/3. 1/3 minus 1 is 2/3, minus 3/2, and then t to the 3/2 minus 1 is 1/2, right? Now since there are negative exponent, you want to move that to the denominator, 1 over 2, and then t to the 1/2 plus 7 over 3 t to the 2/3 minus 3 over 2 t to the 1/2. So you can enter this this answer, or if the Weber sign doesn't like this, you can write 1 over 2 root t, right? Because root t is t to the 1/2, and then plus 7 over 3, and then cube root of t square, right? And then minus 3 half, you can write 3 over 2, and then that is root t on the top, right? Root t. So you can simplify your answer that way, so that you can get the final form that the Weber-Sine like. Okay. Next is, there is 10 over sine x minus 3 cosine x over cotangent x. How do I do that? Let us simplify. What is 10 over sine x? This is like 10 times 1 over sine x. What is 1 over sine x? It's cosecant x, right? Because cosecant is reciprocal of sine. I haven't found out the derivative yet. Okay, I'm just simplifying. Minus 3, this is cosine of x, right? And divided by cotangent is cosine of x divided by sine of x. So if you simplify this, you will get cosine x. So it will look like this. So just this term, okay? If I simplify that term, you will write cosine of x over 1 times sine x over cosine of x. And cosine x will cancel out. So basically this is 3 sine x, okay? So y equals to 10 cosecant x minus 3 sine x. Okay, now find out the y prime. What is the derivative of cosecant x? 10 is there. Cosecant x has derivative negative cosecant x cotangent x, right? So let me write down that negative sign at the front. Cosecant CSCX times cotangent x minus 3. What is the derivative of sine x? Derivative of sine x is cosine of x there. So cosine of x. That's it. Now the last example on this page is basically find the equation of tangent line at y equals to that. What is the equation of tangent line? Y minus y1 equals to m times x minus x1. So x1 and y1 are given. X1 and y1 are given. We need m. But what is m? M is the derivative, right? So at 1 comma 0. So let us find out the m equals to f prime of x, or basically y prime, right? So what is the negative 9 times 4x to the 4 minus 1, right? Plus 11 times 2x to the 2 minus 1, and then minus 0, right? So m at x equals to 1, m is basically negative 36, because that is replaced by 1 to the third, right? Because that value is 3, 1 to the third is just 1. Plus 11 times 2 is 22, times 1 is 22. So your m is negative 36 plus 22 is negative 14. So what is the equation of the tangent line then? Y minus y1 is 0, because that is x1, y1 equals to negative 14 times x minus 1, right? So if you simplify this, you will get y equals to negative 14x plus 14. That is the final equation of the final answer for equation of the tangent line. So we will basically see some more examples, okay?